Okay. So, right. Uh, the agenda of today's webinar is we're going to talk about the three C's of mobile apps testing. We're going to talk about how mobile apps testing is different from traditional testing. We're going to talk about certain challenges that comes in our way as testers when we, deal with mobile apps testing, and what kind of right strategy that we should adopt, while we do this mobile apps testing. And we're going to talk briefly about a mobile test ecosystem that we at Magic have developed for our products. And this is not a something that is a standard, but this works for us, and we don't mind sharing with all of you. And we encourage all of you to try this, and at your workplace, and if there are any modification, any suggestion that work with you, kindly do share with all, because we believe that collectively we can create a standard test ecosystem that works for mobile. We're going to do demo of a small product that we have, and which will basically enable you to see how we can cater these challenges. And in last few testers have shared certain questions with us. So what we have done is we have identified few top important questions, and we have tried to answer them as. So this is the agenda. If there is anything that you have concern or question, please raise, and we'll answer. So moving on to the introduction of Magic. So Magic is basically 25 years of experience in technology and content for edtech space. We are headquartered in New York, and as far as testing team is concerned, we have 150 dedicated testing experts who are kind of segregated into automated and non-automated tester. So we do all kinds of testing, and our team is as big as 150 testers. And from the work point of view, we do provide services, testing services, and we do provide the products for web and mobile testing. So we have our own products that we have built. We use it for services, and as well as we give licenses. And today we are going to demo one of the products for mobile apps testing. And brief about myself: I work with Magic as a senior manager in testing. I'm a software test consultant. I'm a product owner and manager for two products that we're going to show look at today. I am a quality advocate, and I am a speaker. And this is my social media contact IDs. So if you want to tweet to me, you are free. You can email me, and you can contact me via Skype. Okay, so before we start, we're going to talk about types of mobile apps testing. So this just I want to give a brief of to all those who don't have any background of mobile apps. So we have three types of apps, mobile apps. We have native, which it's a kind of app that live on devices and take advantages of all device features. You can work offline in it. The other one is the web. It's kind of a website, but it's looks like a app which is run by a browser and provides you native functionality. So the web components part of it runs like this. And the third one is a hybrid, which is kind of combination of the top two, native and web. So it provides you the both functionalities, and the advantage is that you can use the device features, like network and all, and you can use the web components as well as to point out to certain external elements. So these are the three types of applications. Today we are going to talk about automation of native and hybrid apps. Okay, so let's take a look at the market share of the mobile OS. So if we look at the overall OS share, this is the worldwide data collected on 5th of March 2016. So just 2 days old. And if you look at Android is a dominant player with 51.75% across the globe, while iOS is 32.15%. So and others include the Symbian platforms and some other platforms that are in place. So collectively they are like 16.1. And if you look at the OS version, basically you can see the segregation that how on iOS the iPhone is using 18.54% of the market, while the iPad is using the 13.61% of the market. And these kind of data helps us to as a tester, when someone asks us that, hey, I want to test on Android, we ask, what kind of Android are you talking about? Are you talking about Android 5? Are you talking about 4.2? Are you talking about 5.0? Are you talking about 5.1? So this is the kind of data that we have. When we ask questions, we compare the requirements, and we just don't believe that, hey, someone asks us that test only on 5, because the user may be using anything, user may be upgrading their devices, and your app could be in deep trouble when these kind of changes happens on a device. So this is the background, and now what we are going to do is we are going to jump to the main thesis, this which this webinar is focused on. So I'll be talking about the code first. Now the problem is with all of us is that most of us don't come from the coding background. Many of us do still do manual testing, and these are the types of mobile apps. So these were native, web, and hybrid. Okay, and I hope we all understand what the native, web, and hybrid mobile apps are. So I just thought I'll take a second to explain it again. And this was the market share that we were talking about. So Android is a dominant player, preceded by iOS, and then in last we have some others like Symbian and others. And this was the OS version. So it's a segregation that we have based on iPhone, Android, different versions of Android, and all these kind of things. I've shared the source as well in the bottom, and after this webinar, we're gonna share these slides with all of you, so you can take a look at the share and how we use this data. So now coming to the main agenda. So we are talking about the code problem, and we all have this problem that most of us are coming from non-automated background. Most of us in the testing teams, they haven't done any kind of coding at all, and suddenly the requirement is automation. They are asked to code, and what happens is mobile, the seriousness or the problem you know uh, become worse. So what kind of issues do we see when we talk about the mobile apps automation testing? So not all testers can code. Mobile automation tools are not mature enough. I've worked on various mobile automation tools, and I have seen that although they claim to be cross platform, there are only two who are very good at supporting cross platform automation. We'll be talking about, we'll be seeing these tools, and we'll be talking about what how false their claims are. The third problem is that the external code, that is the test code that we write as our automation scripts, they can't talk to every mobile app. So the idea behind this is that if your test code is not able to talk to the app or to the device, you can't automate those features. And that's okay. So external code, by external code I mean the test code. The test code can't talk on every mobile app, and this is the problem sometimes that we face, that we are not able to talk to device, and the automation feasibility of lot of uh, features fail, and that's where our percentage of automation goes down. So this again is one of the problems. Now we are going to talk about the coverage problem. So whenever someone asks us to automate, what kind of coverage can you provide while you are planning to automate? And what happens is sometimes the testers see that, hey, I can give you 20% coverage, I can give you 40% coverage, I can give you 80% coverage. But the main problem starts that when we start to automate, we see that a lot of things are we are not able to automate, and hence automation fails. So The problem is the mobile apps are although lightweighted, but they have all the features. The scope is not less as compared to web apps. So whenever we are planning to automate mobile apps, we must make sure that we have done a proper automation feasibility before we start automating, before we start estimating the automation effort. The apps use a lot of device features. What happens is when you start automating it, you come to understanding that you are going to automate not only the app features but also uh, the features that are provided by the platform. For example, in Android, if your app uses network, you're going to do something to change the network settings or any other thing. For example, using a camera or uploading an app. So your scope goes way past the app and must cover the device functionality as well. Okay, the next one is that you can't automate everything. Now this is an important because certain apps don't expose as objects. For example, flash based object, we don't see any kind of objects in it. So you can't automate everything, and you as a tester, you should not promise anybody that hey, everything can be automated. you know uh, One another thing is this, in this point is that certain developers, they don't follow practices, good practices, and what happens is that they don't enter object IDs. They don't enter relevant unique IDs through which you can start and identifying attributes. So what happens is that your object identification fails and your code is not able to talk to the app or the device. So this is again a bad development practice that kind of hits us as a tester, and we kind of face trouble. So this is where your pairing with the developer comes into picture, because you have to ask them that hey, your proper development practices must be followed. All the objects must have unique IDs or various attributes, because it may happen that you are using different attributes for identifying different objects. And then the most important thing in the coverage is that how many devices do you test your apps on. So for example, I have done a survey with around where 70 participants participated, and we asked them different questions on what kind of devices they test their apps on, what various details about the different devices that they use while testing, and the difference between the dev and the test team. So the devices that the test team uses and the devices the dev team uses to do unit testing or while developing the applications. So the results were pretty surprising, because the average number of devices that came out were three. So most of the teams were only testing on three devices. This is average, by the way. There were few teams that were only testing on one device, and that to their own personal devices. And there were teams that were using like 6 and 7 devices, and the average was coming out to be three. And that was not pretty good a number, because we're going to talk about it, and we're going to talk about what is a good number that we should suggest as testers. Okay, and the last part of it is the cost. Now, cost is important because mobile apps are low budgeted. The cost of automation must not be too high, because your app uh, development cost is too low. Although we are not saying that your automation cost or your testing cost should not exceed the development cost. It can exceed, it may exceed, but what I'm saying is that overall as a product, you have a budget. And what happens is sometimes automation is helpful, but because of the cost considerations, the high cost, you are not able to afford automation, and hence your testing suffers, your product quality suffers. So as a tester, we must educate our product owners, our clients, that hey, the cost of automation is high because of certain reasons. Now this is part one. Part two is, as a tester, we again have to educate, and we have to find ways that the cost of automation should not be too high. It should be designed in such a way that you should have those options where the cost goes below. And we're going to talk about how we can achieve this. The mobile device costs add spice to the budget. If you talk about iOS devices and Android devices, each device, if you talk about 20 devices, we're going to talk about an investment of $3,000 to $4,000, and this is a very high cost, and sometimes these devices are failure prone, so the cost of management also adds to the overall cost. Okay, so mobile automation testers, they are rare to find and they are pretty costly. They are highly paid, and what happens is if you plan the overall budget, so the cost of automation, the cost of device, the cost of automation tester, it all adds up to a very high cost, and it all goes beyond the budget, and hence certain times what we see is we don't get approvals for the automation budgets. Now we're gonna look, having look at this code coverage and cost, we're gonna look at how mobile app testing is different. So we're gonna see, various, attributes of mobile app testing. What attributes, contributes to making it different. Okay, so not all test works everywhere. A test that is written on an Android might not work on iOS. The app, although the features are same, but their implementation may differ. You know you may end up with more tests for ideas because of the different screen size, different resolution, different OS, different brands. This means that you have to write more tests. This means that your test effort increases. A typical user story in mobile has more tests than if we compare it to a web user story. Now, the hardware and the software dependency on in mobile apps testing is pretty high because you are directly dealing with the hardware, and due to fragmentation, which we are going to talk about next, we are dealing with too much of hardware changes. So you may require devices of various screen resolutions, various network, for testing your apps. You may require devices of various OS brands for testing. Mobile apps need more scenarios, test scenarios, because of high complexity of mobile apps. These are very complex apps because what you're doing is you're taking a web app, you're taking all the features and you're compiling it into a 5-inch, 4-inch a mobile app, and which should provide the same kind of user experience, the same kind of feature set, within the smaller screen. And you do require a lot of more types of testing because you need functional testing for stability, you require performance testing for speed. The device does not have that kind of hardware which is like web. You can have 64 GB of RAM and all these kind of things. So mobile devices are pretty low in hardware configurations, and hence your performance matters. Your device should not be hang, because of your user experience should not change. So all these kind of different considerations, what it adds is it requires that lots more types of testing to be done on a mobile app rather than on a web app. Now we are going to look at some of the challenges that we are going to we face while we do apps testing. Okay, so the first issue is the fragmentation. So there are three types of fragmentation that we are dealing with. First is the device fragmentation, the other is the brand fragmentation, and the third one is the OS fragmentation. The other challenge that comes is the screen size. Now, the question is, if you have different mobile devices, what all kind of screen sizes that you should be testing your app on. Then the next is the OS usage. So, what kind of OS usage you should be testing your app on. And the last one is the testing tool. So, what kind of testing tools am I going to use to test these apps, right? And again, I'm reminding you that you can use the chat to type in any question at any point of time. Feel free, and we'll answer it. So we are gonna now, what we are gonna do is we are gonna go in details and look at these challenges more into details. So first one is the device fragmentation. Now look at this chart. This chart talks about how the different devices are distributed. in global space. And this chart is only for Android. Now if someone asks us that, hey, does your app work on all the devices? Now look at how many devices are you going to test your app on. It's literally not possible to test on each and everything and can satisfy all users. We can't do it. But as a tester, we have to come up with a strategy that should ensure that most of the users have a really good user experience with the app, be it functional experience, be it user performance, be it speed, be it network, be it anything. You should have a good user experience. Now, the important thing is that we discussed that the test teams use three devices to test. Now, we did a survey on a number of devices, and we found out this data. This shows the number of test devices that is required to cover the percentage of Android devices. Now if you are testing your app on 7 different devices in Android, you are only able to attain 25% of the coverage. And by the way, these 7 are unique devices. you know uh, Again, if you increase your devices count to 32, your coverage is gonna 50%. If you increase it to 107, your coverage is 75%. If you increase it to 254 unique devices, you're gonna achieve 80%. And with 399, you're gonna achieve 90%. And I'm sure you can guess what is the number of Android devices, unique Android devices, that we require to test 100% of the device coverage. Okay, so this is the brand fragmentation on Android. Samsung leads this, but again, you have to see that if you are planning to test your mobile apps, what should be the preference of the devices. If someone asks you that, hey, my users, I think it's again an assumption of a BA or anybody who's writing down the requirements that, hey, I think you can test one each on Samsung, Sony, and let's say Google Nexus. So you can come up and say that, hey, Samsung is fine, but I think LG, Sony, Motorola, they all have good space in the market. They have a good user reach, and these kind of data, these kind of metrics that we maintain, this tells us when you talk to BA, when you basically inspect the requirements or validate the requirement, you kind of give them the evidence that, hey, this chart shows me that Samsung is pretty important, followed by LG, Sony, Motorola, and all these kind of things. And this gives you a rough idea that how testing should work out. Okay, now look at this Android OS fragmentation. In fact, this is for Android and iOS both. And if we look at it, this is just till 2015. I think it is not very up to date, but it shows that how many versions of OS we have. Now, if someone asks you that, hey, give me Android 4 and 5 coverage, you are talking about so many Android platforms, with so many devices. So this gives you an idea that how mobile testing is different. For web, you don't get so much of updates. And but in mobile, you have such a variety of upgrades available that you don't know which user is using which version, and you have to make sure that you are testing your app on each and everything. Now this is a kind of increasing the complexity of mobile apps testing. This is how mobile apps testing become more and more complex. And this is the screen size, so we are going to look at different screen sizes. Now what happens is the Android ones on the right hand side and the iOS one on the gray side. Look at the different screen sizes that are available to you. So the idea is that you must choose a wide variety of devices with various screen sizes. You can choose a phone with a 5-inch or a 4-inch or a 3.5-inch, or a tablet starting from 7-inch to a 9-inch, 9.1-inch, 10-inch, and more than that. Now, this is a pretty interesting and important data. Now, look at the OS usage trend. What kind of OS, when you recommend devices as a tester, you know, you have to recommend that what kind of OS are you going to test your apps on? What devices you want with what kind of OS? So, if you look at the Android adoption trend, you know, still Lollipop is leading with 34%. Marshmallow is although just 1%. Ice cream sandwich is 2%. Gingerbread is 3. Jelly bean is still you know in use by 24%, and Kit Kat is 36%. So if you look at this data, if you are covering one at Jelly Bean, one at Kit Kat, and one on Lollipop, you're covering uh, around 90% of the OS in Android. Similarly, if we go on iOS, we can see that most of the users have upgraded to 9, iOS 9, and this is the data. So if you are testing on something on iOS 8 and 7, you're just testing on 20% of the OS usage. Your users, only 20% users are still left on 7 and 8. So why are you testing on iOS 7? Why are you testing on iOS 8? This is the kind of question that we should be asking, and this is the type of data, as a mobile apps tester, we should be maintaining each and every day. If it's tough, we should be maintaining it at least a week. We should be keeping an eye on what kind of changes are happening in the mobile workspace, what kind of OS changes are happening, and we should also be knowing that, hey, why users are upgrading to 9.x, why were there any bug fixes, any kind of platform functionality has changed, because this may impact your testing. You may need to write more test cases. This may impact your coverage, right? Okay, the next one is the mobile tools. Now the mobile tools, in mobile we have a problem that there are more frameworks than there are tools. And if you look at this on the left hand side, we have certain tools that are, most of them are open source. These are for the iOS, and the right one are for the Android. And the list is pretty big, but the biggest problem is, in fact, is that none of them are stable enough. None of them provides good stable functionality. And the other factor is that you don't have support for any of them. For example, if you take WebDriver, there are lot of documentation available on WebDriver. When it actually comes to WebDriver on using WebDriver on mobile, you don't have too much of documentation available. There are a lot of scripts that are ready-made available for WebDriver on mobile, but what happens is that when you start using them, when you start utilizing them, you'll find that they stop working. They don't work in your particular environment, and what you do require at that point of time is a support, that whosoever has created it or whosoever has used it in past, they may come and help you out. Or maybe you should go ahead and try doing some R&D stuff, invest some time on that script and make it work for you. But you don't have time in the real time environment. None of us have enough time to basically deliver our projects. So we don't have these kind of R&D time in our real life. And what happens is that these tools doesn't come handy when we go on a live project. So if you look at the cross platform support that these tools provide, so only 4 tools are there which do claim to provide cross platform support. Now these are the claims. If you have used so what my experience shows is that only Calabash and APM are the two tools that are enough to provide you the cross platform coverage. WebDriver and Siesta are basically the tools which claim to provide a lot of things, but basically they are not able to sustain in the mobile world. Again,
Another challenge.
okay, so the next thing is the 4 things that we basically look at while we evaluate the tools. So first is the coverage. What kind of coverage this tool provides? What kind of features does this tool has? Uh, the other problem is that a lot of mobile app tools, they require re-signing. Now, for example, re-signing problem is much more bigger on iOS because Apple restricts re-signing of apps. So what do you do? How do you do re-signing of apps? The other one is the documentation. You know, APM is great, but where is the documentation? If you are stuck, who's gonna help you out? WebDriver is good, Calabash is good, Siesta is good, but They don't. There are a lot of documentation that are available on the web, but there is no one place where you can find all documentation relevant to your need. And then, since these tools are maintained as an open source project, there is a very less support that is available online. And in fact, I have uh, talked to a lot of testers who are using these tools, and I have asked them, and they are pretty frustrated that, whenever there is a need of support, they don't get that kind of support, readily available. Okay, so what is the right testing strategy that we should adopt? We have seen the problems. We have seen the problems with code. We have seen the problems with coverage. We have seen the problem with the cost. We have seen how device fragmentation is a problem to us because we may have different OS, we may have different devices with different brands, different screen size, different resolution, and it all adds up. Adding up more devices adds up to the cost. So how should we test? What is the right strategy to test? So the first strategy we should have is that expose your apps to compatibility checks. You should make sure that your app is compatible with the device that your user has. So the compatibility testing should be the first testing that, as a mobile tester, you should be performing on your mobile app. It should be performed on all mobile apps that you should be testing. So fragmentation, the goal of compatibility testing is that fragmentation should not be a business problem. The business should feel confident that my app, whenever I'm launching it, it should be working. It should work fine on each and every device. A simple ILU check can provide you more info about your app. So, we're gonna see a demo of a tool, and we're gonna see how this compatibility check can be automated. So you don't need to perform these compatibility checks manually. You have to define your correct metrics to track your compatibility status. So, for example, this ILU check, you have to define that what all kinds of metrics are you, collecting, that you are for your app. And the most important thing for doing compatibility checks is that don't use emulators, use real devices, because your users don't use emulators. They work on real devices, they work on real hardware. So you should be confident while you are testing on real device that, hey, I am pretty confident because my user is gonna use this real device. Now, this compatibility testing comes with a cost because we discussed that it kinds of resolves the problem of fragmentation, but then the number of devices, the number of checks, they kind of increases the cost. So you must have always access to real devices from different vendors, different OS, different screen size, different resolution. So the number of devices is gonna increase. You require a lot of testers with lots of time because testing your app, compatibility testing of your app on every device, it requires a lot of time. If you are doing it on your own, if you're doing it manually, you require a lot of time, or you require a software that can help you with compatibility check. So our recommendation is that you should use a software. There are a lot of ways you can automate this compatibility testing, and we are gonna look at one of the ways to automate this compatibility check. The first part was compatibility. The next part is the functional coverage. So the second step of the testing strategy should be ensuring that your app is functionally covered. Your all the functional features of your app are covered by at least one single test. What this means is that you have to choose a balanced approach towards functional testing. You should not be overdoing it, but you should not be underdoing it as well. Everything feasible should be automated because you can choose to run these tests again and again as part of your regression cycles. So you have to perform automated feasibility checks to on your app to find out what all thing can be automated, and wherever the feasibility passes, you should automate it. But there are still many things that you can't automate because we discussed that there are a lot of features where you don't get object IDs. There are a lot of mobile technologies like Flash which does not expose you objects. So there are certain things which can't be automated, and you have to plan your testing in such a way that it is always complemented by non-automated testing. Now, the other important thing in the functional coverage is you have to shift your testing lab. You don't wait, for a build to come. You can go and validate the functional aspects of a app in the design spec itself. You can go and validate the requirement itself. In Magic, what we have done is we have taken this strategy as a philosophy, and it kind of works for us because we have been working with Fortune 100 companies, and we have seen a lot of defects in the requirements and in the design specs. And if you fix, by the way, fix validating requirements is pretty cheap. It is low cost affair, and if you fix those defects, you're gonna reduce the overall cost of the testing. The third consideration is the choice of tools. So we do recommend certain tools, but then when you are evaluating a tool, the important thing is that you are looking at the cost of the tool. Open source tools also have cost, by the way. The cost is your time which goes into the R&D of those tools. The cost is the time when you look out for the support and you don't get support. So many of us think that open source tools don't have a cost, but if you go look at the effort that goes into installing the open source tools, configuring the open source tools, making it work for your particular project, it is kind of a cost that adds. The features it provides, the platform support and the technology support. Most of the tools that we have seen requires a lot of coding to be done. They support only few languages where you can write code, and then you have to juggle with the testers that hey, you need to learn Java, you need to learn Python because this feature can or tool can be using this particular language. And the support availability. So like I said, these tools are pretty immature and they don't provide a lot of support because they are open source. So now we have looked at compatibility checks, we have looked at the functional coverage, and now to ensure the additional coverage, the third part, you can look at the performance, you can look at the user experience, you can look at the usability of the app, you can look at the security, you can look at the network. So these are the kind of types of testing that you should be additionally planning once your compatibility and functional features are stable. So once your compatibility testing is done, only then you should proceed for functional testing. Once your functional testing is done, you should proceed to do any additional kind of coverage that you want to provide with your testing. Okay, so the last thing that we're going to discuss today is the mobile apps ecosystem, and then we're going to jump to the demo of a live tool, and we're going to look at how we can do some automated testing. So this is a mobile test ecosystem that we have built for us, and let me take some time to explain it to you. So look at the left top corner. So you get a build, and what you do is you expose it to first to the compatibility testing, and what we have done is we have in Magic we have created a tool called AppITest. The URL is www.appitest.com, and what you can do is you can expose your app, upload your app on AppITest, and you can check for compatibility on different devices. What it does is it hosts a lot of devices, and it gives you the gives you a way to test your apps automatically on different real devices. So we have a lab which hosts kind of 150 plus devices, and you can test your app on 150 plus devices without writing a single test. And the important part is that through API test you don't have to write a single test. This is zero test, fully automated compatibility checking system. Okay, and I'm going to demo it to all of you so that you can take a look at how powerful this tool is. The next thing, when the compatibility checks are done, either you get a pass or a fail. If fail, you go to log the defect in a defect management system and you get a next build, and you again expose it to the compatibility check. So this is the kind of workflow that goes, that a build comes, it goes to compatibility using API test. If it fails, it goes back and you get a new build, and then again you follow the same path. If the compatibility, you are satisfied with the kind of compatibility coverage that you have, you expose it to the functional coverage, where you strategize that what kind of features do you want to automate and what kinds of features you don't want to automate, and whatever you do, you expose it to again to API test, which also helps you to run your functional test using Calabash and other tools as well. So what it does, it provides you the feature, provide you different ways to test your app for compatibility and functional coverage. And after these two things are stable, the compatibility and the functional coverage is stable, you expose your app to non-functional, where you should be doing additionally user experience testing or usability testing or performance testing or security testing or any other kind of testing that you want to do. You can do it to ensure additional coverage of these things. So this is a sample ecosystem that we have created for our organization. And we would like you to, if someone asks you that how do you test mobile apps, you can also propose to follow the same structure. And what we are gonna do is we are gonna jump to a demo and see that how we can use API test to test our apps for compatibility testing and functional testing. So Budhini, any questions that you have? Any questions while we jump to demo? So you can type your questions if you have any. So this is a portal, appitest.com portal, and this is where we can log in to it. So I'm just signing it. Okay, so I'm on a dashboard where I'm seeing Android and iOS platforms, and these, I can either choose the Android or iOS, and I can start my testing on. At the bottom of this, I see my different projects that I have created in past, and it shows me all the runs that I have. Now what I'll do is for the demo purpose, I'll just choose Android for this demo. So when I click on Android, I am on the next screen where I am gonna write some project title. So let me say webinar. Okay. Now all it's asking me to upload a APK file. So I'm gonna go and upload a APK file. Okay. Now on the right hand side, if you see, I so this is the compatibility on the tool type. This is the type compatibility testing is selected by default, but it does provide me Calabash as well. Now, if you look at the PPT back, Calabash was one of the tools on Android and iOS that provides us functional testing capability. So we do provide Android functional automation using Calabash, but for this demo, we are gonna just choose compatibility as is. Now the other option is event count. Now this event count is basically a series of gestures, events, actions that a user perform on a mobile device. For example, it can be a swipe, it can be locking down a device, it can be zoom in, tapping, it can be anything. You know, changing your network, accessing your settings, volume up, volume down, brightness, any kind of thing that you can do with your mobile device. So these are the what I have done is I have given a project the title. I have selected a APK file. I have selected a tool type as compatibility check. I have selected the event count, and I'm saying upload and continue. And now it's showing me different devices that I have for Android. So I can select two devices. So if you look at the details, there are devices with OS 4.1, 4.4.4, 4.0.4, 5.0, 5.0.1, 5.0.2. So they have different OS, they have different CPU, they have different RAM. Some have 3 GB of RAM, some have 2 GB of RAM, others are with 1 GB of RAM. They are of different brands. So I can so in my account, so this is a demo account which I use for demo, so I can only see 8 accounts. But for a real user, they can see 150 plus devices. So what we do is we select all and we click on execute test. So if you look at the flow, what we have done so far is we have done given the project title. we have selected the APK file, we have selected the compatibility test type, and we have selected the devices. We are not writing any kind of test to check our app that we have uploaded for checking compatibility of this app on these devices. We are not writing any test at all. This platform is fully configured to run those 3000 gestures, on your app. So what I do is I click on this execute button and my run is scheduled. So I go on this project, it's showing me pending, okay, and it's showing me the status at the bottom as running. Now if I click on view report, I can see my test running on, so it's showing me is so, we discussed about ILEU, and this is what ILEU is. It stays for install, launch, execute, and uninstall. So what we do in compatibility is we install the app, we launch the app, we execute those 3000 gestures that we have, events that we have selected, and we uninstall the app. So what we do is the intention on the of the compatibility is that, you know we are making sure that your app should not crash or it should not throw any kind of errors while these gestures are being performed. So if I refresh this page, it's still showing zero. So I think we can go all are in progress. So it may take some time. So what we can do is we can look at some past reports that we have. So this is the report that I ran in past, and look at this is the kind of data that we saw after the tests are completed. So for example, I chose 8 devices and all were success. Now this is pretty simple to see that, hey, the test ran on 8 devices, everything was passed. So what's the advantage of compatibility testing? What's the advantage that we are seeing with this tool? So we if you look at the installation time, this is a data that we have gathered. uh, you know this is very precise to a millisecond. And if you look at it, one of the device, Desire 820, it's taking 6 seconds to install the same APK file, while there are devices like Galaxy Tab 1 or Motorola, X2, or look at Galaxy Tab, which are taking, almost 6 times the time it requires to install the same APK file. Now, if you do it manually, you don't see a difference of 15 seconds or 5 seconds. But if you are looking at this data, you can easily compare that how my app is behaving differently on different devices. Now, if you use emulators, right? What emulators does is they use the resources of the system on which they are running. So you can't have genuine results if you are using emulators or simulators. But on these real devices, you are seeing that, hey, what kind of difference in when you change the devices, because Galaxy Tab from Samsung has different hardware than what Motorola may be using, and there is a difference of 3 seconds on these two. Now 3 seconds is fine. I'm as a product owner, I'm fine with 3 second difference. But 15 seconds and 35 seconds, there is a huge difference between the same vendor, Samsung Galaxy Tab 1, and the Samsung Galaxy Tab. There is a difference of 20 seconds while I'm installing my product, same product. So why is this different? So this is the kind of data that these kind of compatibility checks gives you. If I look at the launch, so by launch, what we mean is, whenever we have an app on a device, we click on that icon, we tap on that icon, and it launches the app on the initial screen. So this is what launch is. And if you look at, they are pretty consistent in launch. So as a product owner, I should be very satisfied that, hey, this is pretty fine. If I look at the execution part of it, now all the 3000 test cases, the same gestures being performed on the same app on different devices, they are taking different times. Now one may go and ask the development team that, hey, why this difference is there? Why at one device, Motorola is taking 28 seconds, and why Galaxy Tab 1 is taking 48 seconds? Why the other Galaxy Tab is taking 69 seconds? So you should have certain kind of you know explanation from our development team that, hey, why these kind of differences are there. Now what you can provide to developer is that you can provide them the screenshots while these screenshots were taken in random, and you can provide them the execution logs. Now these execution logs are pretty detailed enough, and if you want, you can export it. You can attach it to your defect management system like Zira or anything what you use, and you can send those and share those to your development team to look at it, that hey, why the difference is there. So you can download the whole report. You can download the parts of it. You can download different sections. You can do whatever you want with this detailed report. And the other thing is this, the installation. And so if you look at, it took 7 seconds to install on Galaxy Tab. So now if you look at the whole ILEU section, Galaxy Tab has certain degraded performance with respect to. So now it can be a device or a hardware malfunction, or it can be an app malfunction. So we have to look at these logs. We have to share these with development team, and they have to verify that this is not a app's problem. This is a device related issue. Now the other thing is that this we can do this, that if this is a device specific issue, can we do anything with the app? As a tester, we should raise these kind of questions to the development team, to the product team. What can we do to our code, to our app, to make it work on all the devices, right? So this is the kind of testing recommendations that we as testers should provide at the end of our test execution. Now let's go back and look at what kind of report we have for this run that we have run. Oh, we have this all pass and everything is successful. So if you look at again the installation, so 2 seconds, 3 seconds, 6 seconds, 4 seconds. So if you look at this app, there's not too much of difference between the installation time. If you look at the execution, oh, there is a difference. See, look at this. Someone is a single device. Motorola is taking 71 seconds, while Galaxy Tab is taking 117 seconds. And you can also look at a video. This app plays. So this is the real-time video. What it's trying to do, where it's tapping, it's doing brightness, it's changing settings. So this is the calculator app that I'm using, and it does a lot of things. While it does all the. So this is a real-time video that was captured while the tests were running at the backend. Any questions at all before? So this is the compatibility testing. This is how the automated compatibility testing you can do with API test. And API test also provides you functional testing as well. So if you want, you can go and choose, instead of platform compatibility, you can choose Calabash. And what it does is it requires you to upload your test file as well. Now what happens is in this compatibility. So Amy is asking a question that these speed related things are device specific rather than the app specific. I mean, we don't know. We can't be sure to say that these are device specific. These are not app specific. So what we have to do is, what we do normally in our circumstances is that we take these screenshots, we take these logs on different devices, and along with the videos, and we share it with the dev team, the Android developers, if you are using an Android app, and you ask them to basically go and debug, the app, that hey, you can go and reproduce. So these logs are pretty detailed enough. They can tell you at what point of time they were hitting, what particular event took how much of time. You can easily get out from the log, and you can then ask a developer to basically debug your code and see why it's taking too much of time. So it may happen, in most of the cases, that it may be a hardware related issues. But as I said earlier, the real question is that you have to find out, can we make our app work when we know that on Galaxy Tab, let's say on the Samsung Galaxy Tab, your app is having some degraded performance, some speed related issues. Can we do something within an app to make sure that these kind of things are catered, these kind of things are solved, right? Because we know in advance that there is a problem that our users gonna face. So what all kind of things. So as a tester, we should be raising issues. As a tester, we should be raising risk, and this is one of the risks that we have seen, that we are seeing a degraded performance on Samsung Galaxy Tab in comparison to Motorola. And as a tester, it's our duty to raise that, hey, I am seeing a risk. I don't think it's good enough. I don't care whether it's a hardware issue or a app issue, because our app's code is going to talk to hardware. So can we write a code in such a way that it's talking to all kind of hardware and still giving us a good performance, right? So we can still leave the final decision to the product owner, but we, as a tester, we have to raise these kind of issues. We have to find these kind of issues and raise it. I hope I answered your question. Great. So in Calabash, what you are supposed to do it, you have to upload a APK file as we did in compatibility test. Plus, you are supposed to upload your test file as well. Now, Calabash, you write your offline test and upload it to API test, and the next screen will be the same. Devices screen. You selected the devices whichever you want to run your test on, and you just do execute. And again, within few minutes, depending upon how many test cases you are running on, how many devices you are running, you will get the report back. So this is how compatibility testing and functional testing works with this product, which we have created, called API test. So, a few testers, they gave me some questions. They sent me some questions, and I'm gonna answer those questions. So the first question was, what are the best practices to follow to test different screen sizes of the mobile devices? Now, I want to. So I was talking to this tester who has raised this question, and I think we discussed in detail before this webinar. So, first thing I want to highlight is there are no best practices. So I've given a reference link which explains why you should not talk about best practices, because it that particular practice which you're talking about, it may be best in your particular context, but it does not work best in all the contexts. So you can say that there are good practices and you can alter them to suit them requirement. So if I'm the tester, if I'm allowed to redefine this question, I will rewrite it as, what are the good practices that I can follow to test my app on different screen sizes, right? Now, to answer this question on different screen sizes, you have to find out that which devices are popular in the areas where your app users are located. You don't have to necessarily test on all the devices. You have to be very careful in choosing what kind of devices are you testing your apps on. You can't test on a single device. You can't test on just few devices, but you have to make sure that your users, whichever device they are having, you are testing on most of them. You are making sure that your test plan or test strategy should reflect that by using X number of devices, I am ensuring 30% of my device coverage or the fragmentation coverage. So this is the kind of data that you as a tester should be providing. By the way, the screen size is a design consideration. So you must be validating the data behind it. What I mean by it is that whenever we get requirements as a from BA or product owner, we are often asked as tester that, hey, I recommend you to test on these devices. You know, you should not blindly trust that data. You should have question that data. You should have ask for some reasoning. You should have some validations run on it, and can go online and can find out that, hey, is this data correct? Is this data okay to follow? Or you can, as a tester, you can do some recommendations that, hey, by the way, this data does not apply to this kind of app because my users are located in a geography where iOS is more popular than Android, or vice versa. So you have to find out that what kind of different devices that you want. What is the popularity? Are they just using, because I am creating an app for let's say students, and they prefer big screen size, right? While I'm creating a app for a user who prefers a handy device which he can put or she can put in her pocket and carry it all the times. So it may depends upon the kind of users that you are developing your apps for. And again, it changes from users to users. Okay. So the next question is, what are the standards that are to be followed in mobile testing? So basically, it's a very good question basically. So there are no comprehensive set of standards, software testing standards. So for mobile testing is still lagging behind if you compare with global software testing standard. So there are certain standards that touch upon software testing, but what happens is that they overlap, and they contain contradictory requirements. So you can't trust any of them. IEEE have certain standards, but with all the years of experience that I have, I don't recommend touching base any standard. So because they kind of conflict with the definitions or the processes that they define. So what this means is that we as a testers, we don't have any good testing practice or any single source of information. So what we have to do is we have to share our experiences, like we are doing in this webinar, and we have to collectively see and gather what all different kinds of testers are seeing in the real world, and then collectively we have to take a decision that what kind of practices apply to our context. This is all context driven. We have to see what applies to us, what does not apply to us, and then we have to derive the cost, among what applies to us. Okay, now this is again a very good question. Can you list few defects that are seen commonly in various mobile apps? Yes, we can look. Now, the most commonly, if you go on a Play Store and see different apps ratings and the comments you have, it says that hey, this app does not work on my device. It does not install at all at my device. The another important comment that I see on Play Store, it crashes when I on the app icon. It means that I'm able to install the app, but I'm not able to launch it. Somehow it does not support the hardware that I am carrying. The other thing which I have seen personally on my mobile device is that my phone's battery heats up when I use the app. So this AccuWeather app has a feature where you can select different geolocations. So for example, you can download this AccuWeather app on Android or iOS, and what you can do is when you are traveling abroad and you change your geolocation. So for example, I'm in India, and if I travel to UK or US, if I change my location to US or UK, you can see your phone heating up. You can you can literally see your phone heating up. And this is a bug that we discovered while we were doing some weekend testing, and we reported this bug to the app, but I believe it's still open, still not fixed. Okay, the another thing is that the app crashes when I switch networks. This is a very common issue that we observe. So what you have to do is you are installing an app over Wi-Fi. Turn off the Wi-Fi, go to mobile data, and sometimes what it happens is your app crashes. Okay, on professional apps, you people complain that they are seeing too many ads, and it kind of decreases their user experience. They are not pretty happy, and this is again a defect. Although you are as a company, you are earning through these ads, but it should not happen that you are losing your users with too much of ads. My phone batteries discharges faster when I use the app. This is a common issue which I think you all can. So for example, take any game, and especially Candy Crush. So if you play, so the data shows, even Candy Crush acknowledges, if your the battery rate is 50% and you start playing Candy Crush, within 3 levels your battery will go down 30%. So this is the kind of data that we have. Okay, yeah. There is no way to log out. Now, there are certain apps where there is a login feature, but there is no way to log out. Now, few companies say that you are using a personal mobile, that there is no requirement of a logout. But then it's a user who says that there is. I want to log out. I don't want to log in because maybe my family is using that mobile and they see all my bank balances and all. So there should be. This is a design consideration. There should be a feature to log out your app. And the other is it hangs or slow down on mobile networks, on 2G, 3G, and different other networks. The application hangs the mobile device, or it slows down the mobile device. The performance of the mobile device slows down. Maybe it's using too much of resources, the native app. Because other defects which we can think of is when going from online to offline mode, several of the features stops working. You don't see a sync when it goes back online again, from offline. Okay, there are certain questions which were asked, which due to lack of time we can't cover. But I think we have covered in past that common challenges we face in mobile application testing. We covered these were fragmentation, the screen size, uh, the requirement of compatibility testing tools. What are the tools that we use? So API test is one of the tools, cloud-based tools that you can use for testing. Is there a way not to incur device cost? Yes, you can use cloud-based platforms, and you don't incur any device cost. You just pay for per device per minute cost. And the important thing is, if your dev and test teams are based out of different geographic locations, is there a way to test an app on same device without buying two copies for each team? This is a very good question. And in fact, through API test, you can use it because your all the teams can have logins on API test and on any cloud-based tools, not just API test, and you can use it. So the recommendation is that if you start using these cloud-based mobile app test tools, you get it's a kind of a collective space where you get all the tools stored at a single location. It gives you access to physical devices, and you don't bother maintaining them as well. So any questions, because we are done. Any questions at all, you can ask via audio, or you can chat, type in the questions. Buddhini, any questions with the audience at your end? Emmy, cool. Thanks, Emmy, for attending it. I hope you'll find a test useful. Buddhini, you have any questions? We can't hear you. Can you please type?
Last time we had about 5, 6 lecture if you have missed it. So hope if you have any questions, please.
Raise your hands. Do you have any questions? No? But you can. We can ask. So, shall I say no questions at the moment?
Yes.
Cool, Buddhini. Thank you. Thank you, everybody, for joining it. Have a nice day.